Imagine waking up in the morning, grabbing your phone, and within a fraction of a second, reading a message sent to you from the other side of the world. A few taps and you're watching a live video feed from Japan, ordering food from a local restaurant, or checking the current temperature in Reykjavik. But how is that even possible? How can all of this happen so quickly, so precisely, and so reliably? How does the internet actually work? The internet isn't some magical invisible force floating through the air. It's a highly complex system built on physical infrastructure, mathematical protocols, and billions of interconnected devices. To truly understand how it works, we need to start at the very beginning. Back in the 1960s, the US Department of Defense initiated a project called ARPANET. The idea was to create a communication network that could survive even if parts of it were destroyed, an essential requirement during the Cold War. ARPANET introduced a revolutionary concept, decentralization. Instead of a central hub, data could travel between any connected nodes. Over time, ARPANET evolved into what we now call the Internet, a vast global network connecting billions of devices worldwide. Today, when you type a website address like www.wikipedia.org into your browser, an astonishing chain of events is triggered in less than a second. Your device sends a request via Wi-Fi or mobile signal to the nearest router. The router forwards the request to your internet service provider. From there, the request is passed through a series of switches, routers, and nodes until it reaches the server that hosts the website. The journey is complex, but it all happens in milliseconds. To make this possible, the internet uses a system of unique identifiers called IP addresses. Every device connected to the internet has its own IP address, something like 94.131.1731. But since no one wants to memorize strings of numbers, we use domain names like google.com. When you type in a domain, your device contacts a DNS server, the domain name system, which translates the human-friendly address into the numeric IP address needed to find the correct server. Now comes the most mind-blowing part, the physical internet. Most people think data travels by satellites, but in reality, the vast majority of global data transmission occurs through undersea cables. These thick cables, about the size of a garden hose, stretch across entire oceans, connecting continents. Inside them are bundles of optical fibers that transmit information using pulses of light. These pulses blink at speeds far beyond human perception, and every flash carries a piece of data, a 1 or a 0. Once your request crosses the ocean, it arrives at a data center, massive buildings filled with specialized computers called servers. These servers store websites, process information, and send back the content you asked for, such as a web page, a video, or a message. The response travels back the same way, through cables, routers, and wireless signals, until it reaches your screen. But the data doesn't travel as one big file. It's split into thousands of tiny packets. When you stream a video, for example, your device is receiving hundreds of small packets, each containing a portion of the content and instructions on how to reassemble it. If any packet gets lost, your device will request it again. This system ensures that your experience remains smooth, even when the network encounters minor problems. What about wireless internet? How do signals reach your phone when you're not plugged in? That's where radio waves come in. Technologies like Wi-Fi, LTE, and 5G use electromagnetic radiation to transmit data. An antenna sends out a signal which travels through the air and is picked up by your device. The device then converts that electromagnetic energy back into digital data, which can be displayed, played, or saved. Wireless transmission is incredibly fast but slightly less stable than fiber optics, especially over long distances. The internet relies on standardized communication protocols to function. The most well-known is TCP/IP, TCP, or Transmission Control Protocol, makes sure all the packets arrive and are put in the right order. IP, or Internet Protocol, handles the addressing, ensuring every packet knows exactly where it's going. Think of TCP as the person who organizes the pages in a letter and IP as the postal service that delivers it. Security is another crucial component. When you enter your password or credit card details online, you don't want anyone eavesdropping. That's why encryption is used, most commonly through HTTPS, the secure version of HTTP. Before data is sent, it's encrypted into unreadable code and only decrypted by the intended recipient. If a hacker intercepts it mid-transit, all they'll see is nonsense. Email platforms, messaging apps, and online banking all use various forms of encryption to protect your data. And here's something fascinating. The internet has no central brain. No single authority runs it. Instead, it's a decentralized system where governments, universities, companies, and individuals all maintain different pieces of the puzzle. Yet thanks to shared protocols and standards, everything works together seamlessly. If one server fails or a cable is damaged, data reroutes through another path, kind of like how traffic finds new roads during a detour. Every second, billions of data requests zip across the globe. People are sending messages, watching movies, video calling friends, making online purchases, and playing games. Every click, every swipe, every search sets off a digital domino effect that circles the world and returns to your device faster than the blink of an eye. And a most incredible part? It's all built on just one thing: moving ones and zeros from one place to another. Whether you're on a laptop, a phone, or a smart fridge, what's really happening is the rapid switching of electrical or optical signals that encode binary data. That's all it takes. Despite AI, VR, and massive cloud computing, the core idea of the internet remains what it was half a century ago: a system designed to connect us. The internet is the most powerful invention of the modern age, unseen yet everywhere, insanely fast yet still reliant on blinking lights and glass cables. And that's what makes it so breathtakingly real. Subscribe us for more videos.